Let us move on to question 8. Question 8 reads as follows. Consider a sequence of words containing symbols A and B. The first word in the sequence is B. Right, so you've got a sequence. I'm going to put them from top to bottom. The first word in the sequence is B. Right, the word number N, so this is the first word, let's call it 1. The word number N, so this is the first word. The second word, for instance, is obtained from the word N minus 1, the previous one, by replacing each symbol A with the symbol ABA. Now there is no A here. Okay, so you can't replace any of these with ABA. But there is also another rule, replacing each symbol B with the symbol A. All right, so this B becomes A. Right. And then, okay, we've got the rule now. So the next one is obtained from the previous one by replacing this A by, what is it? ABA. So wherever you see A, you put ABA. All right, so that is your third word. The fourth word, okay, we'll break it up into 3 groups here. The first A becomes ABA, the B becomes A, and the A becomes ABA. Okay, let's just write the fifth word as also. Okay, now this part here becomes, the first A is ABA, the B becomes A, the A becomes ABA. And this A here also becomes ABA. And this is exactly the same as the first. So it will be ABA, first A, the B here becomes A, and the last A becomes ABA. So now you got the fifth word is this long string here. Okay, you'll notice that you've got 7, so what has happened here is that this entire thing merges into the front. So it's ABA. This part here is this, so we just merge these 3, and then that, so you got 7 symbols here, and you got 3 symbols here. So the length of this is, the third one is 3, the length of the fourth one is 7, and the length of the fifth one is 773, which is 17. So the lengths keep jumping up like this. Okay, and then if you count the number of A's, yeah, okay, let's carry on. Now, what is the smallest value of N for which the word N contains 2025 symbols of A? Okay, now this is your N. N is the number of this. Now, it contains 2000 and at least 2025 symbols of A. This has got no symbols of A. This has got 1. The next one has got 2. Here you got 2 plus 1 plus 2, which is 5. Here you got 7. No, you got 5. Yeah. Well, the whole thing. merged here. So it's 5 plus 2 plus 5, which is 12. All right. So if the nth word has, say, small a, a's, and small b, b's, the n plus 1th word has, okay, so how many capital A's have you got? Okay, each of these A's, they create two A's and a B. So the number of A's is doubled. So if you've got two A there, the number of A's is doubled, and the number of B's, there's a B which is born. So there is a new B. This A creates, see, if the A's, there are three A's altogether here, three small A's, and two small A's are capital A and small a, and one A capital B, because each of these creates an A. A single B. So let's now what happens to the B A's, the B B's? All these become A's. So the B ones, they are added to that one. All right. So the number of A's is 2A plus B, and the number of B's is just A. Okay. So you can see, like for instance, this is n plus 1th word. It's actually equal to 2A plus B. So if you multiply this by 2 and add it to that, you get this. Let's just be a little bit more precise. Now just remember, you got two, the number of A's increase from little a to its double plus the number of B's. And the number of B's is not is the number of A's, right? So if you count the number of A's and B's in each word, right, you've got this nice formula. Okay, let's get on to, I just want to show you the next slide. In this next slide, I use what I discovered here, right? So yeah, I've got a record of the number of A's we saw is 12, the number of B's is 5, and I'll also include the length, the full length of this thing. You see, when you merge them, these are supposed to be merged together, but I've just separated them. So the full length is 17, and here the length is, let me, this is my pointer. So you see you got 3 plus 3 plus 3 plus 1 plus 3, that gives you 7. 7 plus 3 plus 7 is 17. Right. And you'll notice that each one all right, so the number of A's, this the number of A's is 12, in the fifth word when n is equal to 5. By the way, this is n. N. The nth word. So we said just now that the number of A's increased from double A plus B. Is it? 12. Now this one here is double the previous one plus 1, which is 4 plus 1, 5. And this is double this plus that, which is 2. So you can see the formula works. So you're going to have 29, double this, 24 plus 5. And the number of B's is the same as the previous A's. So now you got this. So let's do this all the time. You got 58, double it plus 12. 58 plus 12 is 70. And here the number of B's is 29. And I want to see when does the number of A's increase to be at least 20, 25. So I'm going to sort of work this by hand for the moment. So yeah, you got 140 plus 29 is 169. 70 comes down. This, you double this, is 338 plus 70 is 408. The 169 comes down. And this is 816 plus 169, which is 985. 408 comes down. This is 1970 plus 408, which is 2378. The 985 comes down. So you can see the number of A's keeps increasing, and the first time it exceeds 2025 is on the 11th word. So that answers the first part of the question. The first part is which is the first word which has got more than 2025 A's? Like this, the 10th word has got 985 A's, and this has got 2,373 A's, 378, and the 225th word is the A is in the 11th word. Now there is another part to this question. So what is the position of the 2025th A, the actual two in this word? So the question is, oh, yeah, this is where I want to be. So the thing is, this word here has got 2000 and so we need to know what the length is. All right, how long is this word? So here you have 29 plus 12 is 41, right? Because you got the word is made up of only A's and B's, and you got 29 A's and 12 B's, so that makes 41 symbols altogether. And you just keep adding these. Add those two, and this one here is 1393. I think, and this is something 323353, I think 3363. All right. So now this thing, this 2,378 word, has got 3,363 symbols in it. And in those symbols, we want to know what is the position of the 2025th word, position of A, the 2025th symbol in this long string, right? What is, if I write down these 3,363 symbols, A and B, what is at which position is the 2025th A? You see, like for instance, now if I take this, I've got how many A's have I got? I've got 12 A's. I ask what is the position of the ninth A? Okay, the ninth A is there's 12 A's altogether. The 12, 11, 10, 9. This is the ninth A. Now, what is the position of the ninth A? It is 7 plus 3 is 10, and the position of the ninth A is 13th, right? There are 17 symbols altogether. You get 13, and you get 14, 15, 16, 17. So the position of the ninth A is 13. So here it's the same question. What is the position of the 2025th A in this long string? So how do you do that now? Okay, the way to do that is you count the number of A's. So you've got 985 A's in the previous one, right? So this 2025 is made up of several A's. Okay, so suppose we start counting from the front, and you're looking at the 2025th position. Now the 985 A's in the first part. Remember, we merged these things. See, this one is merged to get the first symbol. So you got 985 A's. So let's take out that 985 because we want to get to the 2025th symbol. So now you got the rest here. Now, again, there are 985 A's here as well. Okay, we want to get to 2025. So let's take 2025, this one here. We'll subtract 985. You get 1040 remaining. Okay, so you've got 1040 symbols here. Let me just take this. This is an error here. Right. You've got 1040 symbols. And you can take out another 985 from that. From those 1040 symbols. And you'll be left with 15 more to get to 1,000 and 40 over. So it's 55. You still got 55 symbols to go. Now remember, this 985 is coming from a word which has got length 1393. So you have to get 1393 symbols from this 3363. Right? You take 1393 symbols, and in those 139 symbols, you got 985 A's. Right? You're still running short. So we take the next 1393 symbols together 985. So here you got another 1393 symbols, which contribute 985. And you still got 55 more A's to cover. Now, how is the 55 A's made up of? Right? It's coming from this symbol here is, this string has got 480 A's, that's too many, 169, 70. But here, this has got 29 A's. So this, you take the string which has got 29, right? And you're still left with 26 here. The string which has got 29 has got length 41. You'll have to keep track of that, right? These lengths here will lead to this position that we want to get to. So it's important to keep track of the lengths. So now you've got 26 left. So which of these contribute 26? 26 is too small here, but you can take out 12 from there, right? Take out 112, and that's coming from a string of length 17, but it's still too short. Right, so you have to take out another 12, which has still got length 17. You're left with 2. Now that 2, we can get it from here, right? There's the 2. Okay, and now I get 0. So your 2025th A, all these, if you add up all these, you got 2025, right? And these are the different lengths which produce this. So the position of the word will be just to add all these things. You have to add the 2 also here. Now this one will be 3. You see, the word that contributes to this 2 is really this one here, ABA. The length of that word is 3, and the position of the word is 2. Okay? So you have to add this. So what is it? 3, 6, 7, 21. I'm sorry. 6, 7, 21, 28, 31. That's not what I wanted. You got 3 plus 3 is 6, 7, 14, 21, 24. Right, that's what I wanted. Right. 2 and 9 is 11. The 11 and 9 is 20, 24, 25, 26. 2 and 3 is 5 and 3 is 8. 1 plus 1 is 2. So the position of the 25th word is 2864th position. See, the last A is The very last is coming from ABA. Okay, that's why I had to add 3. All right. Now, that was quite a mouthful. I can tell you that I really struggled with this because I was working on the actual construction of these things, and it was really weird until I discovered that it's much easier to do it like this. Okay, after much trial and error. So if we clear all these drawings and I get on to show you the actual solution, you see these numbers here, 3363985. And these are the numbers that I did get by calculation. And then I argue it out here, which is not a very good argument. But in the end, you come to 2864. All right. But I took a shortcut to get the 985s because you'll see the 2025, 985. But what I did was when you add these 3, you get 985. So that's why I put 985 plus 985. I took out the 985 from the remainder one time. I know that what the length of those 3 words are. All right. So that takes care of problem number 8, I think. We get on to problem number 9, question 9. Okay, now question 9 is a geometry problem. In triangle ABC, angle ABC is 110 degrees. So ABC is 110 degrees. Well, it's split. There's a 40-degree angle which comes out to meet this line here at Q. Right? So, and then from angle C is 50 degrees, but you draw out at 20 degrees. So PCB is 30. So you draw out 30 degrees from PCB, from line CB, and it meets this at P. And the question is to calculate. So oh, okay. Angle ACB is 50 degrees and ABQ. ABQ is 40 degrees. Anyway, this picture tells you the whole story. You've got angle B and angle C. They are split. This is 40-70, and here you got 20-30. And you join this, and the question that is asked is, what is the angle QPC? So it's this one here. All right, you might think, well, this is an easy problem, angles and all that. You do this, in grade 8 and grade 9. Some of the angles of a triangle. Okay, but it's not like that. At least in the triangle, the large triangle, you've got 110 here and 50 here, so that makes 160. This is the large triangle. So we can say that this angle is 20. Okay, you can calculate that. But as far as these other angles are concerned, you got no way of doing this thing. Because 40 degrees is here. You can say 20 plus 20 is 40. So this angle here is 40. This is the exterior angle to this triangle. So I can say that angle is 40. So it's the same as this angle here. So it means that these two pieces are the same. because the small triangle here is isosceles. 20 plus 20 is 40. Okay, and then you got 40, and 40 is 80. So you can get this is 80, and so this is 80 also. But that's where it stops. 80, and this is, if this is 80, this is 60. Anyway, this is 70 plus 50 is 120, so this is 60. And this angle here, this angle inside here is 80. Because 40 plus 40. But now these other angles here, we can't get any more with that. You can't make any further progress to get to that angle. All right, so you get stuck. So you have to find some way of trying to solve this problem. And evidently you'll need a construction because you can't solve it as it stands. Okay. So what is the construction? If you look at this thing carefully, let me just clear out all these drawings here. You see, one of the things I notice is that this angle is 40. This is 20. It's half of that. So if I draw another 20 here, if I draw another 20 here, then this angle here becomes 40. And that angle is 40. So I can create a cyclic quad, provided I extend this thing and produce this line, BQ, extend it to meet this one. I have a quadrilateral where one of the sides subtends 40 degrees here and 40 degrees here. I'll have a cyclic quadrilateral. Also, I got these two angles are equal, which will allow us to make some interesting calculations. All right, so let me do that. It takes a long time to discover that. We try all kinds of constructions, but this construction here works. So that is what I've done here. So this is, I've redrawn this diagram and I've drawn my 20 and I've extended this line here, BQ, to meet this line here at R. Right, now I want to see whether I can use this diagram to calculate this angle here. That's the angle that I try to calculate. So what do I notice about this diagram? There are quite a few things you can notice. Okay. For one thing, this is a cyclic quadrilateral. That is the whole purpose. If this angle here 40, this angle here is 40, and this side subtends, if you take PQ, PR, PBR is 40, PCR is 40, this side here subtends equal angles at C and B, so PBRC is cyclic. I presume that you know things about circles by now. If any line in a quadrilateral or any side of a quadrilateral subtends equal angles at the other 2 points, then that cyclic quadrilateral, then that quadrilateral is cyclic. is a circle that contains the 4 vertices. All right, and once you know that the circle contains 4 vertices, you can say that every side now becomes a chord, and therefore each of those will subtend equal angles at the other 2 points. Okay, like for instance now, there's a 30 degrees here. PB subtends 30 degrees. So therefore, this angle here will be 30 degrees. PB subtends equal angles at R and C. And also you got RBC. RC subtends equal angles at B and P. So this is 70. So we know this entire angle is 70. But we're still not, we don't know this angle here. If we know this angle, then we can calculate what that is. So do I know this angle? All right, you do know this entire thing is 70. This is 40. 70 plus 40 is 110. So this angle is 70. If this is 30, this has to be 40 then. Okay, now, yeah, but now this angle is 70. That angle is 70. So you have this triangle. The triangle in red, I got 40 degrees, 70 degrees, and 70 here. So the triangle in red is an isosceles triangle, and the vertex angle is bisected. Now, we've seen this many times. When you got an isosceles triangle, the vertex angle is bisected, or you draw a median, or you draw an altitude from this remaining vertex, you are going to create 2 identical triangles. They are congruent, and it's perpendicular to the other side. So this figure here tells you that this point C, because these 2 triangles are congruent, this triangle, let me show you which one it is. This triangle with this, and this, right? It's got equal sides on the side, it's got equal angles, and there is, yeah, and 2 angles are the same. So these 2 triangles, 2 sides are an included angle. So therefore you got congruent triangles. And that allows you to say that this point C lies on the perpendicular bisector of, so these are equal by congruence. And these angles will be 90 degrees, right? Because your isosceles triangle is split into 2 right angle triangles. Every isosceles triangle is like this, right? But now, earlier on, I told you that now this becomes, this line here, AC, becomes a perpendicular bisector of PR, as you can see. PR is now bisected. This point here is midpoint, 90 degrees. So the AC is a perpendicular bisector. And I mentioned earlier on that any point of the perpendicular bisector creates an isosceles triangle. So these become equal. And now this 30 degrees here now plays an important role because this is an isosceles triangle. So this is 30 then. and the whole angle is 70, so your question mark is 40. Actually, this is a much more interesting figure. We wouldn't go into it, but you can investigate it. Uh, we've got the answer. The answer is 40 degrees. See, because this is 20 degrees, this is 20 degrees, you also have your Z angle. This thing here is parallel, like that. And then you also have that R, you see, we said that RC is equal to CP, when these two triangles are congruent. But then you got this is 70, and this is also 70. So you got that this RB is also equal to this one. And then you have that APC, we said earlier on, you got 2020. So you got that kind of a thing. So you got AP is equal to PC is equal to CR, and AP is also parallel to this thing. And therefore you got AP is equal and parallel to RC. And then one of the theorems in geometry is that if you got two sides of a quadrilateral are equal and parallel, then that quadrilateral becomes a parallelogram. So this quadrilateral now is a parallelogram, but the adjacent sides are equal. This is equal to this. So you not just have a parallelogram, you got a rhombus. APCR is actually a rhombus. It's a parallelogram with adjacent sides equal. And in a rhombus, you have that the diagonals bisect each other at right angles. So we've got not only is this angle, these two equal, you even have those two equal. See? So there's a lot of interesting things about this. Although we're starting with funny looking angles, 20, 30, 40, 70. It doesn't look as if there's much of a story there. Usually with 60 degrees and 45, you have a story. Anyway, I just thought that all those things are rather interesting. That's beyond finding the solution to the problem. So let's get on to the next problem. Oh, you see, I've got here without any construction, I actually calculated this angle theta using trigonometry. You can see you got a lot of trigonometry here. That's very good for those people who are familiar with double angles and so on and so forth. You'll be able to use your trig to come to the solution. Right? It's not very easy, but as you can see, in the end, in the penultimate line, the line just before the last line, you see, yeah, you see you got sine theta equals, you got exactly the same story, yeah? So you can see from inspection that theta must be 40 degrees, right? Which we calculated using geometry, okay? And then I got the actual solution, which I gave you. Now, that's the geometric solution. So you can have a look at that in case you didn't understand certain parts of what I said. Okay, now that takes me to the last question, question 10. The question 10 is a strange kind of a problem. A rectangular pie is cut n minus 1 times vertically and n minus 1 times horizontally. Let me just draw this. So there's a rectangular pie. So this is cut horizontally and vertically. So the cuts are parallel to the sides. So you have it's cut like that into smaller rectangular pieces. So you have all these are parallel now, maybe like that. And then it's also vertically cut. Okay. But it's cut n minus 1 times vertically, n minus 1 times horizontally. So the number of cuts in both cases are the same. So I've got 1, 2, 3, 4 that way, and I've got 1, 2, 3, 4 this way. So that's fine. So this is the kind of situation you've got. Now you've got n squared smaller rectangular pieces, as you can see. A cut n is 5. N minus 1 times O. N is 4. So it's 1, 2, 3. So you got 3 cuts. And the number of rectangles is 16, 4 squared. So that's how you get n squared smaller rectangular pieces. Now, it turns out that the areas of the pieces, when rounded to the nearest integer, are equal to integer numbers. Okay, they are rounded off. These areas are not integers. We nothing said about whether the sides of the rectangle are integers or what. You just got a rectangle which is cut. But you can round off. So you've got, for instance, if this one here, if the actual area of this one here was 2,34, right? When you round it off, you use, I think we use a symbol like this maybe to say it's rounded off. You say it's 2, right? So when you're rounding off, you take the nearest integer to that number, right? I'll call you later though, yeah. Mhm. Yeah, so you take all these areas are not whole numbers, but they say that when you round all of them, they are integer numbers from 1 to n squared because there are 16 here. So you get the 16 numbers from 1 to 16 are all inside this. So the areas, now these become the areas of the pieces when rounded becomes integers. All right, so the question is now, in such a case, determine the largest value of n for which this is possible. Like if I start rounding up these things, some of them may be the same, right? You can't put all 16 numbers in here. If 2 of them are the same, then some of them will be missing. So that's the question now. All right, now what I'm going to do is I can rearrange these cuts so that the widths keep increasing this way. Okay, let me do this actually. I can take this piece here, stick it in there. I think this width is bigger than this, so I can take this piece and stick it right in the front and put this one here next to it and then this one is smaller than that. So you can rearrange them so that they are increasing this way. Okay, somewhat it looks as if they're increasing, right? And now you can do the same thing this way. So rearrange this. So they're increasing this way. You just cut horizontally now and you place them. So we can make this assumption. Make this assumption. So then the very smallest one will be at the top there. So this area here is A. And if I call this A and I call this B here and C and D, the corners, let's just give the corners names. Then what happens is that we've got that A is less than C. It can't be equal because these are all, when you round them off, you get different integers. So you can't have A and C equal. All right. And you also have A is less than B. In fact, these keep increasing here. A is smaller than this, smaller than this, smaller than that. And A is smaller than this, smaller than this, smaller than that. And I can assume that B is smaller than C. Now you can do that because if it's not, then you just tilt the rectangle around. Right? You tilt it 290 degrees and you will have this C coming down here and the B there. All right. So you have A, B, C, D in that order. All right. So you can assume that B is smaller than C. Now, actually, C is even smaller than D. So you have A is smaller than B, smaller than C. Now, I claim that C is actually smaller than D. We don't know that. Okay. Yeah, how do you do that? So what I'm going to do is I'm going to give the sides of this, we'll call it XY, and the sides of this PQ. So you got that A is equal to XY, the area, and the area D is equal to PQ. These symbols, X and Y, are the sides of the rectangle. And the area of a rectangle is length times breadth. Okay, but this is also P here, right? P translates. And here you got X here. And then here you've got Q. And here you've got Y, right? And you have the AD, the product of these two diagonally opposite areas is actually equal to PQXY. But what? The area of C is PX. C is not equal to PX, by the way. C is the actual area. Oh, wait a minute. No, C is actually equal to PX. Sorry. Right. It's not an integer. So, and B is equal to QY. So you multiply PX and QY, you get, it's the same as BC. So that's interesting that this area times this area is equal to this area times that area. Okay. All right, so you have, I'll just record this important result that the area AD is equal to BC. AD is equal to BC. Now, I said that C is smaller than D. Now, let's just see why that is so. This, you got AD equals BC. We've done this many times using fractions. A, D, and B, C. Right. Now, A is smaller than B, right? We got that. So therefore, A over B is less than 1. Therefore, C over D is less than 1, which means C is less than D. That's what I wanted to show. So you have this situation. A is smaller than B, smaller than C, smaller than D. All right. Now, when I looked at the solution, oops, can I get this thing back? Yeah, I can get it back. Oh, that was a little bit worrying. The solution says that D is the largest and A is the smallest of all these squares. In other words, this D, the area D is actually equal to like this. The, the, the if you round off D, you'll get n squared. In other words, you get the largest area. And if you round off A, you get 1. All right. So it's not only A is less than B, less than C, less than D, but the smallest area is here and the largest area is there. Okay, I can put the smallest area here, but I wasn't able to put the largest area. In fact, I'm not too sure whether that is correct. All right, let's not worry too much about that for the moment. Now I can solve my problem. My problem is quite a tricky problem. It's I'm going to take out all these because I need space. Okay. So there is we we've got this situation here. I'm going to draw it and create space here. So I'm really interested for the moment in just the corners, and you got all these things are so, oh God. So you got all these things divided like this. And you got it. And there are lots of other lines. Right. And then we said that this area is A, B, C, and D, and we said that A is smaller than B, smaller than C, smaller than D. And we also said that the greatest integer for A is 1. The smallest, the numbers from 1 to n squared can be fitted into this grid, and the largest is at the bottom right-hand corner, right? And we want to find, and we also know that AD is equal to BC. When you multiply these areas at the corners, then you have this equation. Okay, now we want to find the largest value of n. Now, to say this greatest integer is less than 1, this means not the greatest, the round off. This means that A, where is it? When you round off A, you're going to get 1. Now, if you round off half, it's 1, not 0. You round it off to the next integer. So you could have A equal to half, but here you have to put a half on this side, right? So there's 1, there's 0, there's 2. You're rounding off something to be equal to 1. That one must be within half a unit from here and half a unit from here to round out to this. And that's why we've got A is from 1 to 1.5 is 3/2. So that is the thing about A. And as far as D is concerned, D is equal to n squared. So you have that in a similar way. You have the D, it lies between n squared minus a half and n squared plus a half. And it could be equal to that, but not equal to the next one. Okay. Now, I can say something about A and D, but I can also say something about B and C. See? Because you got that A is in the top corner here, and B is in the bottom, and you've got several rows. So this is an n by n grid. So I'm just going to say you got lots of things coming to that, right? And A, we said this is increasing. So at the worst stage, you can have the round-offs are going to be the round-off of these squares. Round-off here is 1. You can have 2, 3, 4, and here is n minus 1. The reason why I'm doing that is that I know that A is less than B and these are increasing. So you can, when you really squeeze them together, you'll get to this. So in other words, the rounding off of n minus 1 this thing here is less than B. Because this is, when you really squeeze them together, you get this. And all we know is that this is increasing. See? So if you've got increasing sequence of numbers, integers, I'm looking at just the integer values. The smallest possible value you're going to have here is n minus 1. This is what I'm saying. So the smallest value of, what am I doing? I'm rounding off the wrong thing here. Sorry. The smallest possible value of the rounding of a b is n minus 1. Now, likewise, we know a is less than b less than d. So when you look at the vertical lines, starting from a, and I'm going to look at the columns now. Coming up to d, so you look at the rounding of the integer a, rounding of integer d. Now remember, you've got n minus 1 here. So you have to have the n here. 1, 2, up to n. Right? Okay, this goes up to n because it's n by n. So you're going to have, at the worst possible case, you're going to have n plus 1 here. The rounding off of this is n plus 1, rounding off this is n plus 2, and so on. And you have the n columns. So it's 1 plus, how many have you got? You got, yeah, you see, because you have n plus 1, n plus 2, and then you'll have 2n minus 1. So you're going to get n plus n minus 1, n plus 1. To get n columns here, I have to have n, I've got 1 here already. So I must add n minus 1 columns to n to get 2n minus 1. So in short, 2n minus 1, that is the largest possible value that you're going to have for d. All right, I hope I got all these arguments correct. As you can see, these problems get very difficult because the whole country is asked to solve these 10 problems. Okay, I'm going to create some space here now. I'll call you later, Guru. I just want to create the space. Sorry about these phone calls that are coming in. Now, what I'm going to do here is I'm going to use now AD is equal to BC. Why do I make all these mistakes? That AD equals BC. Right. Now I have that a half is less than A, and D. Oh, let's let's get this thing right. So you have that n minus half is less than or equal to, and for this reason. And that's B, and with D, okay, you got BC is equal to AD. Let's let's sorry about that. BC equals AD. So this allows me to say that n minus half, which is smaller than B, and C is smaller than 2n minus 3 over 2. And when you go down, I should have written that the C is less than or equal to, oh, this is C, man. Right. Okay. So this C. So you got 2n minus 3 over 2. And this is going to be less than or equal to AD. A is less than 3 over 2. And D is less than n squared plus half. Okay, so with all these inequalities, you'll end up with this expression here. And now that gives you an inequality, inequation or inequality equation, right, involving only n. And I'm going to try to solve that for n, and that hopefully will give me the largest possible value of n, which I'm looking for. Right. Okay, I'm sorry, I was a little bit sloppy in trying to establish this, but eventually you get to this inequality that was just written down. So let's just multiply, to get rid of the fractions, I multiply on both sides by 4, 2, 2, and 2, 2. So I get 2n minus 1. Multiply this by 2, you get 4n minus 3. Multiply this by 2, you get 3. Multiply this by 2, you get 2n squared plus 1. So you get 8n squared minus 6, minus 4n minus 6n is minus 10n plus 3 is less than or equal to 6n squared plus 3 again. The 3 is cancelled off, and you have 2n squared minus 10n is less than. It's actually less than, strictly less than. Because I had n minus half less than c. Okay, so you have it's less than. It's important to say it's less than. Very important. Less than 0. And you can cancel the n's because n is a positive integer. So you get n minus 5 is less than 0, and n is less than 5. So the highest value, the largest value of n for which this is possible is 4. Answer is 4. Okay, so that solves that problem. But I just want to point out that in the actual case, when n is equal to 4, somebody has taken the trouble to find out what the actual solution is, how to distribute the 16 numbers into a 4 by 4 grid. Right, so this is, the answer is 4. So you see, they've actually calculated the sides of this. So if you let the sides be 2, 3, 4, 5, and here if you let the sides be the rectangle like this, then you can calculate all the areas. There's your 4 by 4 grid, starting from here. The 4 by 4 grid is this one. And the lengths of the sides are given. So you can see you're increasing this way and you're increasing this way, but you have to choose these numbers nicely. And when you choose those numbers and when you round off, you'll get, this is the exact values because these are not integers here. This is a round of 1, and you'll see all the numbers from 1 to 16 in this. You can see 1, 2, 3, 4, and then go 5, 6, 7. Take the extreme case, but 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So thank you very much for listening. This brings us to the end of the 2025 senior team paper.